Hello everyone. Today I am going to show you the SR flip-flop execution. So here in the programs verilog, I have already written the SR flip-flop program. The SR flip-flop work like this. Here two inputs are considered. The inputs are S and R and two outputs. The outputs are Q and QB. And clock is the again input. So inputs are 1 0 with SR, that means two inputs. Outputs are Q and QB. Always we have to initiate the output with the registers to store the data. So register Q, QB. Consider the clock with the input, and initially Q is started with 0. Always we have to consider the positive edge. We can even consider the negative edge, but we have to look the program outputs at the negative edge of the clock. Here positive edge of the clock is considered, so we'll look the output at the positive edge of the clock. Here again there are four possibilities. Whenever it is 0 1, the output Q and QB are 0 1 only. Whenever the inputs S and R are 1 0, the outputs are 1 0. And whenever it is 0 0, it follows the previous state, and when both are 1 1, actually this is goes into forbidden state. So that's why we have initiated by default Q is equal to Q, and end the case, and QB is initiated with the negation of Q. Now let us see the test bench program. This is the Verilog program, and this is the test bench program. See, in the test bench, always the inputs are considered with the registers. So S, R and clock are the inputs, and outputs are considered with the wires. Q and QB are the outputs. So those are considered with the wire, and instances unit under test are considered for all inputs and outputs, as SR are inputs, SR is to be considered. QB are outputs, so QB are considered, and clock is again the input, so clock has to be considered by default. Now let us initialize the SR inputs with 0 0, and always for 10 seconds. So here we are varying the clock with the negation of clock. So here 40 seconds delay are considered. So with the 40 nanosecond delay, when SR is equal to 0 1, the output is 0 1. When SR is equal to 1 0, the output is equal to 1 0. When SR is equal to 0 0, it follows the previous state. Here 1 0 is the previous state, so it follows the same previous state. Whenever the inputs S and R are 0 0, the output follows 1 0 only. So that is why we have not considered this 0 0 state initially, because it has to follow the previous state. So some previous state has to be defined, and whenever it is 1 1, the output is not defined properly in SR flip-flop. That means it goes into forbidden state. So let us observe. Now let us move on to the digital. Go to open terminal, CSH, to invoke the cadence tool, and source CSHRC underscore test. So here it shows welcome to cadence tool suite, and type nc launch. Now we have got the cadence tool launch. See, in the programs Verilog, we have got all the programs. Now in the work lib, just delete the previous programs. So now the work lib is empty. Go to SR flip-flop. Just click on the SR flip-flop.v and launch the compiler, Verilog compiler. And again go to SR flip-flop underscore tb, launch the Verilog compiler. Now we can observe both comes under this work lib. So just select SR flip-flop and now elaborate the current selection. So this one is elaborated, and also take SR underscore tb, just elaborated. Now both are elaborated. Once it is elaborated, it comes under the snapshots. So in the snapshots, select the TB module. So in the TB module, launch simulator with the current selection. So just select launch TB module. Here two windows will be opened. One is the console window and the other one is the browser window. Just minimize the console window and open the design browser. Here we get the SR test bench simulator. Just right click and say send to waveform window. So new waveform window will be opened. Okay, so now here we have to give the timing. So I'll give 400 nanoseconds. Just run the simulation. Here we can observe the program. Whenever it is 00, here we can observe the states are not defined. That is why we say it is a forbidden state when it is 11. But here if the case is 00, so in the case you can observe, since the previous state is not defined, here previous date is not taken properly. So once the states are defined, when it is 01, the output is 01. When it is 10, the output is 10. Here you can observe 10. When it is 11, you can observe it is into the forbidden state. Okay. So this is how the output waveform of SR flip-flop has to be observed. Thank you for watching the video.